Anyways, sorry, something just happened. There's going to be a break in the video. Okay, so anyway, you have that. Okay. Jupyter uses IPython. IPython is basically a Python interpreter, but it adds a few nice features. The classic interpreter that comes with Python is doesn't have as many nice features. Okay, the classic Python interpreter shell, shows if you see this, okay, as your kind of your cursor indicator, this is the classic Python interpreter. Okay, but IPython will have in and some number. Okay, this is what IPython will look like as far as the interpreter goes. Okay, and so you can do your basic operations. Okay, 2 plus 3 will output 5. Over here, if sorry, let me restart and clear output. Okay, I'm going to go ahead and run this. Okay, so it says in 1 and out 1. Here I have 2 operations in the cell. Okay, as far as the output goes, so the other operations do get run, okay, but only the last operation becomes the output of the cell. Okay, each cell is only allowed to have one output object, and so this outputs an object of 9, and this outputs an object of 25. But only the last object that's output is going to show up as the out. Okay, so this says, what goes in is this, and this is what comes out. So out 2 is 25. If you want the other stuff to appear, you can use a print command. So you can do print 4 plus 5 or print 5 times 5. So it's going to say, first calculate what 4 plus 5 does, and that outputs the object 9, and then we're going to print that result 9. And then here we do 5 times 5, it outputs 25, and we say print 25, and it prints both of those things, and we get 9 and 25. However, the print function does not return a value. Okay? So technically what we've done is we've done a multiply operator, we've done a function that multiplies values, and it outputs, or it returns the value 25. Here, we're basically nesting a function. We're doing 5 times 5, that returns 25, and then we're saying print 25, and it prints 25 to the screen, but print does not return an object. Okay, so because there's no object being returned, there's no out value here. Okay, so this is just the results of the print. All right, so with all of these things that show up as in and out, with IPython, you can actually access these kind of past entries and past output values. So I can use in square bracket 1, okay? So much like you can kind of think of this as almost like a vector in R, and you subset it using the square bracket. It's very much like that. The in is basically a list, and we can ask what it was, and it shows the exact contents, the text contents of this cell. Okay, this contains the text that says pound basic operations, and then a new line character of 2 plus 3. Okay, so it shows exactly what that is. And now this thing is in 4, and this thing is the in the list out 4. Okay, yeah.
If you rerun the first input cell, it would get a new number. Would the indexing still hold, or would it break?
No, it still holds. Okay, so the in 1 will still exist. So if I rerun this, you're right, this will change to in 5 and out 5. Okay, and if I actually just go to this list, which just lists off everything that's so far in, okay, it keeps in 1, Okay, this is in2, in3, in4. Have I lost count here? Okay. Yeah, so in5 is now the duplicate of in1. Okay, so it still holds. In1 is no longer visible in the notebook, but it's still in IPython's memory here. Okay, and so this will just keep growing and growing and growing. I don't know if there's a limit. There might be a limit. I'm not 100% sure. Okay, I don't know that answer. Okay, and then you can also get the output. Okay, and then so like back here, out here was 25, and so if I say what is out here, it tells me that it's 25. Okay, out is technically a dictionary. Okay, and we haven't really talked about dictionaries and lists yet in these data structures, but you can see that there is there's a bunch of these things here. So in1, in2, and notice, I'm sorry, out has an entry for 1, an entry for 2, and there's what? No entry for number 3, because number 3, in 3, were these print commands which return no value, okay? And so there's nothing being stored for out 3. So if you ask what was out 3, it's going to throw an error. It's going to throw a key error, dictionary key error, because out 3 doesn't even exist, okay? And so we have this, and out 6, okay, in was the list, and out 6 currently shows this, and this is what we have here, okay? Is that all right? So in is a list, which we can see here. So a list in Python is similar to a list in R in that it can have mixed data types. You can have integers and things, but everything in this in list is seen as a string, okay? Because it's taking what you have typed into the cell and treating that as a string, okay? And then it interprets that string of text. The interpreter interprets the string of text as commands in the Python language, okay? And then the outputs are a dictionary. The out is a dictionary. So anyway, this is useful because you might want to make reference to some value that that you've calculated, right? So back here you might say, well, I want to use this value 25 for an operation, and or what it might be some complex value, and maybe you forgot to save or store that object or store that value as an object. Okay, you can still reference it by using the out. You can still reference it yeah.
Why would you want to do that rather than go back and fix the error?
I mean, there could be different reasons. I don't know. Maybe the computation took a long time and you don't want to have to rerun the whole thing. I don't know. It's just available, okay? Not to say that this should be your first plan of how you approach the problem, right? So, but sometimes you run something and you go, oh, I forgot to save this, but it took a while to produce or something, and you're just doing it in a pinch. Yeah, best practices is not to use the in and the outs, because as you can see, the in and the out values will be different depending on the order that you run these things in your notebook. And so if you reference out 5 and you tell somebody else to do it, their out 5 might be definitely something different. So it's not ideal, okay? But it can be useful in a pinch. Yeah. Okay. I don't know why I threw this in here. This is just a weird thing that Python does, or not weird. It just does some interesting things. In R, this would not be allowed, but in Python, you can actually do addition and multiplication operations with strings. Okay, addition will concatenate, and multiplication will actually concatenate with by doing this. So I'm just saying, take this string, hello exclamation point space, and make 3 of them and concatenate them all together. Okay, so you can do that. You can say hi plus goodbye, and you can run that. Whoops. And it just concatenates them together. Okay. So so that's allowed. Okay. But there's no subtraction or division. Okay. All right. In the folder, I've got a script here. Okay, script 01.py. Okay, and it is the most simple script possible, right? So I just have print hello world. Okay, and I'm going to go ahead and I'm just going to close that out. So that's what the script is. You can execute scripts within Python. Okay, so this is also a handy feature if you want to like work on a script and be able to execute it inside the notebook, and not have the entire script written in the notebook, so you can reference it from other things. You can do this. Okay, and so you use what we call a magic function. Okay, %run. Okay, and %run will take this and it will run this script here and do and return hello world. Okay, and so again, this script just said print, and so it's basically just running that code, and so it prints out hello world. Again, no output there. Okay. I have another script. This one's ever so slightly more complicated, where I've taken, I'm going to take the variable name, okay, and I'm going to add hello space to name, and that's going to say hello name, and then and it's going to print that, and then it's going to print it's Friday. Okay. All right. And again, just like if you want to include single apostrophes, then you got to make sure you use the quote, the double apostrophe sign to do that. Okay, so anyway, we'll go ahead and go back to our notebook. Okay, and if I try to do this, my name is Miles, and I'm going to run this. It runs into an error. Okay, because it's trying to run this script. And it says, okay, well, I tried to do print hello plus name, and it's giving me this thing, this object name is not defined. Okay, and that makes sense. And so what we want to do is we want to give it the option -i. Okay, and that tells, you know what, this script is allowed to use the variables that exist inside the Jupyter notebook. Okay, so here I've got name is Miles. This already has been executed, and so this name exists inside the workspace for the notebook, and now I can run the script, and it will say hello Miles. Okay. So again, so these are useful things. Yeah, more questions.
Can you pass arguments to the run command, so you could pass in a main argument without having to take from the notebook you're working in?
I'm not sure. Let me think. I feel like maybe, but I don't know off the top of my head. This is I don't know. I'm sure we can look it up and find out. Okay. But generally, yeah, I don't know. Usually, I see the run command as just to, run the script or something. Then all of the things will be defined. But that's what we have there. Okay. You can also just see the contents. You can see the contents of the thing, or just you can use bash commands. Okay, so on a Mac where you're using basically a Unix operating system, you have these bash commands, And to see the contents of a file, you can write something like cat, right? And then you have other functions like grep for like doing regular expressions, and I don't know what other bash commands we have. I'm not an expert on bash by any means. And you can run bash commands by using the exclamation point, okay? And so here, I can just say, well, what was written inside here? And here it gives me an error because I'm on a Windows machine, and Windows does not have a cat command, okay? But it has an equivalent program called type, which just basically types out the contents of the file, and so we can see the contents of the file, okay? But to access those bash or kind of command prompt functions, you just put an exclamation point in front of them, okay? Let me see. More IPython. Let me see. IPython magic commands. So you can learn more by searching IPython magic. Okay, they have a lofty view of self, and so read the docs will be the documentation, and then this looks like someone's blog entry where you can do all sorts of stuff. But let's scroll down to magic commands. Okay, so you can set environment variables, run code, %load, %store, and there's other magic commands. %alias magic, auto wait, auto call. Okay, but so you can read the documentation. That's going to be an important skill. All right, obviously in 10 weeks I can't cover everything, but you'll have to start learning how to read documentation and learn how to use new functions. Okay. I would generally recommend using referencing the main documentation as much as you can. Okay. Another nice feature is you can use the single underscore character to get the last value. Okay, so here if I do 3 times 9, the output is 27, and I can use this last value that was calculated by just doing underscore. Underscore minus 2 will now return 25. Okay, and I can do, you know, and if I just ask what is underscore, it's going to report back 25 as well. So all of these things you can access using a single underscore, the last value, which is I think is handy. All right, and so these are all just kind of nice features of IPython, and there's more that you can do by looking up kind of IPython magic, and it looks like this blog entry has 28 Jupyter Notebooks, tips, tricks, and shortcuts, which I'm sure will be helpful to read. I'll probably read through this as well. You can call for documentation on stuff as well. You can ask for like help on the print function, okay, and it will tell you. It'll print out the documentation for print, okay, with all of these things. Okay, let's see. All right, we got a little bit of time left. We might as well start the next notebook. Okay, so I'll go ahead and I'll what I'm going to end up doing is I'll cut and paste the what we get through, and I'll rename that to 0103 to make sure it matches up with what we said. Okay, so I basically just copied and pasted a bunch of stuff out of Jake Vanderplas's A Whirlwind Tour of Python, which I highly recommend. Okay, So all you have to do is go on Google and search a whirlwind tour of Python, and he's got these notebooks on GitHub, okay, which pretty much I've copied. And then there's also a kind of a PDF version of this thing, and you can just kind of read through this, where he covers just a bunch of basic stuff in Python, okay, and so if you aren't following him, if you go to his GitHub, so if you just type in GitHub Jake Vanderplas, Jake VDP, okay, he's got a couple repositories, and probably the two most popular ones are Whirlwind Tour of Python, which we will take a look at today, and then the Python Data Science Handbook, okay? And this is the textbook that I'm basing a lot of my notebooks off of, okay? And that, again, is available on ProQuest.Safari Books Online, and you just type in Python Data Science, and this is kind of the textbook that we're using, and he's got all of his notebooks on GitHub as well, okay? And so they're very good. I don't think I could have done a better job making these things, so I've just copied a lot of these things kind of directly, okay? So so anyway, comments marked with a hash, okay? This is not a surprise. I think we're all used to this, okay? The end of a line terminates a statement, okay? So you don't need semicolons, so this is what we're accustomed to seeing in R as well, but if you're talking about like C++ or something, you know, no need for semicolons, okay? You are allowed to use semicolons if you want to, though, okay? If you want two commands on the same line, right? So, you know, for simplicity, you might want to do something like this, okay? And if you have something and you want to continue it onto the next line, so if you got like a really long command and it doesn't fit on one line, or for readability you want it to extend on 2 lines, you can use the backslash. Okay, so here I've got x is 5, print x. Here I've got y is 6 and z is 7, and print y and z, and we get 13, okay? And then here we've got a is 1 plus 2 plus 3, and we say continue it on to plus 4 and 5, and we can do that, right? Okay, and if I didn't include this, we would run into an error, because it's going to think a is 1, 2, 3, 6, and then it's going to get confused. What are you adding 4 and 5 to, right? It says, here's plus 4 plus 5, and that's an unexpected thing. Whoops, what happened? Oh, okay. You can't put a space after the backslash. Okay. If you're going to continue on, the backslash has to be the absolute last character in that line. Okay. Or, I mean, of course, you can also use parentheses, and that works as well. And so here, or if you're making a list, it's smart enough to know that here's a comma, we should expect more stuff on the next line. And so here I'm making a list with the letters A and the numbers 2, 3, the letters D and E, and the number 6. Okay, so lists can be mixed content. Python, so this is another important thing, is that Python uses indentation to define code blocks, okay? So in R, there was no rule about having, like, if you say for I and blah blah blah, and then you would open up a curly brace, there was no rule that said the next lines have to be indented, okay? By default, RStudio indented them, okay? And you would write them, and it helped you kind of keep track of what a code block looks like, but there was no requirement that was the case, okay? Python is different. It requires code blocks are defined by the indents, okay? The text that is indented is part of the code block, and as soon as you dedent, okay, or take out the indent, it ends the code block, all right? So here I've got x is equal to 8. If x is greater than 5, it's going to print x is greater than 5 and print out the value of x and then print hello, okay? So when I run this, what will we see? So here, it's going to say x is greater than 5. It prints out the value of x, 8, and it prints out hello. Okay? And similarly, if I have x is equal to 4, it only prints hello because these two lines are associated with the if statement. Okay? So the if statement, because they are indented, these two are associated with the if statement. So you write if, blah, 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 and then you write a colon. Okay? And after a colon, IPython will automatically indent because the colon indicates that you've got a code block associated with some previous statement. So you can make a for loop or whatever, or an if statement with a colon. It's automatically going to indent, and as soon as you dedent, okay, take out the indent, it undoes this. Okay. So what's going to happen in this code chunk? So these two cells look almost the same. The only difference is that here I've got print x indented, and here I've got print x in line with print hello. Okay. So this is easy level question, but what will this output? 4 and hello, right? So x is greater than 5 is not executed, but print x, which is 4, is executed because it's not associated with the if statement. Okay, and so so indents are very important in Python. And so if you indent a piece of a line that should not be indented, Python's going to throw an error. Okay, and if there's no indentation when Python is expecting indentation, it's also going to throw an error. Okay, I think, like if I put 2 spaces here, I think this will cause an error. Okay, so I've got 2 spaces here, and it says unexpected indent. Okay, and by default, I think the indents are 4 spaces. There's not a rule about like, so if you want to do 5 spaces, let's see. That works. Okay, for some reason it's complaining. I don't know why this is showing up in red, but I think. Okay, so the number of spaces that the text is inserted, it doesn't matter. Okay, I think you can do like 2 spaces or 3 spaces or 4 spaces, but it just has to be consistent. Okay, so if I'm going to do 4 and 2, now I've got a problem. But as long as it's, as long as it's at the same indentation level, it's happy. Okay, so and kind of a side effect of this strict indentation thing is that your code is almost guaranteed to be at least semi-readable because all the code blocks will be properly indented. Okay, and so when you code in R, you probably used indentation practices, but if you wanted to, you could make obfuscated code that didn't use indentation, and you'd have a headache reading it. Okay, but that's impossible to do in Python because the indentation defines the code blocks. How far do I want to get here? Okay, well, I'll just start talking about this, and we'll cover this more on Monday. Okay, you have data types. Okay, you've got integers, floating point numbers, strings, booleans, complex numbers. These are all same things that we had in R as well. Okay, Python technically has more types. You've got integers of different lengths, and no, I'm sorry. The integers are unlimited. There's no upper bound on the integers, but technically you have floating points of different levels of precision. In R, we by default use double precision floating point numbers, and that is also the case in Python. But if for whatever reason you are on an application that was trying to save memory, well, you probably shouldn't use Python in the first place, but you could say I want to use single precision floating point numbers and things like that. But we'll talk about these data types, I guess, on Monday, and we'll just start here. I'll probably post your first homework assignment, which first, I guess, like notebook homework assignment where you'll work on it in class. You still have your data camp homework and all of that, and it looks like most of you guys are keeping up with that, so that's good. There's another one due in a couple of days here, so make sure you work on that as well. All right, we'll see you guys on Monday. Have a good weekend.